Good afternoon, everyone. It is 6:30 p.m. Tuesday, August 5th. This video marks the 72nd video in the series. Today we're going to continue on with Greedy. Yesterday we worked on Gas Station, which we were able to solve, and we worked on Hand of Straits, which we were not able to solve, and we need a little bit of help near the end. So, not really happy with that. I feel like Greedy is something I should be able to get on my own, but that one I was not able to. So maybe need to circle back to that on a later date, see if I can figure that out on my own. Today we're going to work on merge triplets to form target triplet. Okay, so a triplet is an array of 3 integers, and I'm given a 2D integer array called triplets, where the triplets of I is equal to these 3 values, and it describes the ith triplet. And I'm given a target triplet, which describes the triplet I want to obtain. So to obtain the target, I may apply the following operational triplets any number of times, possibly 0. So I could choose 2 indices, I and j, and update the second one to become the max of them combined. For example, or not combined, but the max of their values. Okay, so that kind of modifies on the example. So then I return true if possible and false if it's not possible. So 2, 7, 5. So I just kind of merge these two and I can create it. So I guess one way you can go about it is to merge them all, like all permutations, but well, that could be a bit problematic. So I can see it going exponential time, which makes me wonder: is there like some sort of sort I could do? But what exactly would I sort? Would I sort the sum of each array? How would that help me? Would I create 3 different arrays, each of different sort? I don't think so. Let's look at some hints for this problem. So O(n) time, so no sorting, and O(n) space. So I don't need a hash map or nothing like that. This means I should be able to do with the for loop just to be able to go through and figure that out on my own. Oh, you know what? You could do it as long as the max does not go over. So I'll say current is equal to 0, 0, 0. Then I'll say for triplet in range of triplets. Nope. What am I saying? Triplets. No range. I don't need range. If triplet of 0 is less than target of 0, and oh, well, I say less. It has to be less than or equal. Nope. Yes. Honestly, I don't have to check if it equates. I think this should be fine, yeah? I mean, this never goes over. This might be too much operations, but I mean... I think greedy is such an interesting kind of idea because it's so simple, yet your brain always tricks you to trying to do something more complex. And I mean, we'll see if that's the case here. So this could be a lot more. It also has a problem of like even the problems that seem easy are hard. Okay, so this one worked, but that might not always be the case. Okay, well, that works. There you go. So yeah, I use a little bit of extra operations. I can optimize this by reducing the payload of how many times I'm reassigning this. I could do that by making sure I'm not, assigning something like if I already captured one of them, I don't capture them again. But yeah, that one was pretty simple. I wanted to go quite like when I was thinking about solving that, I was thinking about doing it in a way more complicated way. But then again, greedy tends to have a nice kind of solution. Just gotta sit there and think about it for a second. You are given a string S, and we want to partition the string into as many parts as possible so that each letter appears in at most one part. For example, the string AB, AB, CC can be partitioned into AB, AB, CC, but partitions such as ABA, BCC, or AB, AB, CC are invalid. Note that the partition is done so that after concatenating all the parts in order, the resulting string should be S. Okay. So this one shouldn't. This should be oven. There should be no sorting or anything like that. The question is, do we need extra space? We might not need extra space. Or we might do. It could be something of like we get the frequency count. No, but that would, the way I'm thinking about it, would involve too many kind of like array operations. I was thinking like I could store each current item in the subset. Let's see, what time complexity does he recommend? Oven time with oven space, where n is the length of the string and m is the number of unique characters in the string. So that means we want a frequency array. Off rip, that's pretty much what that means to me. So for char in S, I hate when they do S. I mean, like, come on, just put string or something like that, or word. If char not in freak, then freak of char is going to equal to 0. This just kind of creates it, and then right afterwards I'll do a plus equals 1. So this initializes it to 1. So this is my frequency. Okay. So what I'm going to do here, I'm going to say if length of temp is equal to 0 and count is greater than 0, then we will say, we'll have our result equals this. We'll say result.append count, and count equals 0. So this is basically whenever we hit our end. So what temp is going to hold? Temp is going to hold every single kind of variable that is in, or every single character that is in use. Frequency of char minus equals 1. We'll say temp dot what is it? Python Spython. Python set, add, and remove. What is the syntax? I think it was add and... Okay, add and remove, that's it. Wow. Okay. Temp dot add char. And then I'm going to say, well, if frequency of char is equal to 0, that means we got rid of it. Then temp dot remove char. And then I can do count plus equals 1. And then I will do a if count doesn't equal... Well, I feel like I would always have to append the last one, huh? And then result dot append count and then return result. I don't know. I'm actually kind of confused to see if this is even gonna work or not, or even if it's gonna run. Hell, it did. Wow. Okay. I'm gonna submit this before I explain my thought process here. It could be incorrect. There you go. Damn, I'm on a roll. Okay. So what's happening here is I'm setting up this this set, which is a list, but every single element has to be unique. So I can't. It'll automatically delete a duplicate if there is a duplicate. I'm going through and basically I'm saying that if this set is empty, well, that means that basically means that we've used up all of the characters in a certain substring, right? But if count is 0, then there was no characters to use to begin with. Therefore, there's nothing to append. But if count is not 0, that means we did use up all the characters. So exactly what does that mean? Well, when we're going through, we add the character that we're using. So, for example, we have AB, right? So we're gonna add A, or let's do up here. This is much smaller because we're gonna add A to the temp, and our count's 1. We're gonna add B to the temp, and our count's now 2. And we try to add A again. Well, A doesn't exist, or sorry, A already exists, so it's just gonna duplicate that. So it's going to say the set's still going to be AB, no duplications. But it's not going to see that we actually used up all of our frequency because we had 2 A's and we just removed 2 A's from our frequency. So because of that, it's going to remove it. So after this operation, it's actually just going to be B by itself. And when we run to the next one at the very beginning, the length of temp is still 1 because we still have B by itself, and the count is now 3. And then we get here to the second B. We try adding B, but B already exists, no duplication, so it just stays as B by itself. Our frequency goes down 1, and now the frequency of B is 0 because we used all of our B's. So we're going to remove that from our temp, and we're going to increase the count to 4. So on the next operation, when we hit the C, before we actually read the C, we see that, oh, okay, our, pardon me, we see that our, bring forward, our set is empty, and the count is 4, meaning we actually did look at some stuff. So we're going to append that 4, and we can reset the count. And then it goes CC, and that adds 2. So, I mean, hopefully that made sense the way I explained it. But, yeah, we're going to go ahead and look at valid parentheses string. We're going to do that for our last one. So given a string S containing only 3 types of characters, open parentheses, close parentheses, and asterisks, return true if S is valid. So we want to have the following rules define a valid string. Any left parentheses must have a corresponding right parentheses. Any right parentheses must have a corresponding left parentheses. Left parentheses must go before the corresponding right parentheses. So this is just like Matthew rules. And asterisks could be treated as a single right parentheses or a single left parentheses or an empty string. Haha, okay, wow. So we're getting into regex once again. I always feel like I fumble at these problems. I feel like I missed the mark. I'm not truly comprehending it. We'll try again. Let's see if we can hopefully land this one. So what I think I can do is I think I can just run a counter that counts each step. And I'm wondering if I need actually a frequency, which would be extra space, or if I can just do this in singular space. Okay, it's definitely a frequency is what I would want. All right, cool, good to know. So, oh wait, no, counter is not just the simple solution because it still has to be left, right, left, right. Crap. I think the open extra space is for the stack, not a counter. Curious what this says. A brute force stack-based approach. We maintain 2 stacks, one for tracking the indices of left indices, and another for star indices. Oh. I think I understand. We'll call this left star. I'm gonna say for char in S, if char is equal to an open parentheses, then let's say left dot append char. Elif char is equal to a star. We'll say star or asterisk dot append char. Else if length of char is, length of not char, length of left is greater than 0, then we will use left first. Then we'll say left equals left to -1, popping off the end. Elif length of a star is greater than 0. This is using the star. They will say star is equal to star, and popping off the end. If it's not, then we just return false. So that means there's no correlating or matching one. So that goes through that. Then at the shoot. There is one caveat here. Something I didn't think about. I didn't think about the order of operation I put this in. because what I was going to do is at the very end I was going to do a while loop to basically say just pop left and star until, you know, zilch. But the thing is, if star comes before left, then that's not valid. And I would not know how to check for that. Unless I tracked it with the position at each index, which that feels a little bit much. Okay. Okay, so we do need to track the index. Right, okay. I had a feeling. Oh, yeah, wait. I'm tripping. I could just literally... Hold up. This is not even that hard. I think... Like, why was I even adding in... was adding in the char like that even made sense? Like, brother, lock in for me. Alright. We're just gonna put this at the bottom, return true. I'm gonna say while length of left is greater than 0, if length of star is equal to 0 or left of -1 is greater than star of -1, return false. Else, we will basically just say star equals star to -1, and left equals left to -1. And let's see, do we have anything with this? Runtime error, because I said start. Whoops. Let's try that. Infinite, nope, okay, thank you. Alright, nice. Alright, let's try spinning that, see what we get. Okay, well there you go. I feel like this is pretty self-explanatory. So basically, if we encounter a left, we append it, the index, because we want to see where that left was. If we encounter an asterisk, we append it. We want to see where that is, the index. And if we encounter a right, then we need to basically close out that right. So if there's a left that exists, we'll close out with the left, because those ones we have to use. If there is not a left, but there's a star, we'll use a star instead, because the star can act as a left. But if there's neither a left nor a star, we have to return false because, well, we're out of space. And then at the very end, if the left stack still has some items in it, then we need to start checking that. In order to do so, we need to make sure that the left stack items, they come before the star. So in order to do that, I'm basically saying if it's greater than a star, that means it has to be false, because that means it's coming after the star. If it's coming after the star, it's problematic because then it won't properly close out. The star has to come after the left parentheses. And if the length of star, which means there is no asterisk left, but there's a left left parentheses left, then that means there's nothing to match it, so that also returns false. Other than that, then we'll just keep popping. And if we hit the point where we use up all the lefts, it doesn't matter if we have any stars left over or not. We don't need them, or we don't need to worry about them. We just exit the loop and return true, and that gave us the solution. Now looking at this, looks pretty nice. We just have one last part, and that is advanced graphs. And that one's gonna suck. There's 1, 2, 3, 4, 5, 6. Who knows? That might actually take me 6 days to do one per day, because advanced graphs can probably be hard. Or who knows? Maybe these questions are actually easy. Like how 2D DP wasn't actually too bad, so maybe it could be like that. We'll see. But other than that, that is today's video. So that was actually a pretty quick video. It was like about, what, 20 minutes, 30 minutes? We got 3 greedy done, and we finished greedy off completely. Thank you for watching, and I'll see y'all tomorrow.